They talk a lot, but can they hack it? Sending it for 6 off the planet. I was measuring the distance.
So the first thing I'm going to show you is DOUBLETAP. DOUBLETAP, it's a toolkit called DOUBLETAP. DOUBLETAP is essentially a MITM proxy add-on. If you're not familiar with MITM proxy, I'm going to post the link in the chat now. Or I guess I could just pull it up. Keep forgetting, like, you know, to get used to this stream stuff. So, MITM proxy. Like this, you can see how awful of a typer I am too. So MITM proxy is essentially like, you can think of it as like Burp Lite without a user interface. It's completely CLI based, and it's what I expect. It's a general proxy, and it also has an add-on system. So you can write complex shit with it, like really complex shit with it, because they made it in a way where you can just basically add any kind of functionality you want to the proxy itself and interact with various components of the proxy. So and you can hook like requests, HTTP requests, the response and that kind of thing, and you can modify them and all that stuff. So what I came up with, well, not I came up with, but a technique was discovered way back in the day, originally by the Hide and Seek project, which it was a tool written in Golang, if I'm mistaken, which basically tried to automate creating disposable infrastructure for red teams. And the person who wrote that initially, basically discovered that you can proxy traffic through AWS API Gateway. Okay, so what this means is you can take advantage of that and proxy HTTP traffic through API Gateway in order to change your IP address on every connection. And this, from my understanding, this is because like you can use like take advantage of the load balancing that's going on in AWS, and because of the load balancers in AWS API Gateway, your IP address basically changes every time you hit the API gateway, and then the API gateway sends a request to the end server that you're trying to access. So because there's a way of setting it up where, so usually API gateway, it just sends back a response that you program it with, like AWS Lambdas or something. But there is also a way of telling AWS API gateway, hey, I want you to proxy this URL to this destination. So when you set that proxy attribute in the API gateway endpoints, it actually acts like you expect a proxy. So there were a bunch of implementations of tools trying to take advantage of this. There was originally something called Fireprox. There was Hide and Sneak. I think pretty sure that's what it's called. Fireprox was written by Mike Felch, who worked at Black Hills InfoSec. And it was basically just a quick proof of concept to demonstrate, like, hey, you can do this. Rhino Security also came out with a IP rotate burp extension. If you're not familiar with that, I've actually never used it, but I found it by accident while I was building this. So it's a burp extension that basically does exactly this, only a lot less seamlessly and a lot like a little bit more setup involved, and it uses burp, so it's not exactly headless. So I was thinking of ways, because this technique has a lot of like potential, right? But there wasn't really anything that, I guess for lack of a better term, like fully weaponized this. And it wasn't really seamless, even with the IP rotate burp extension or the Fireprox tool. So I decided to rewrite the concept in a MITM proxy add-on. MITM proxy add-on, however you pronounce that. So it's written in Python 3. It's fully async, which is actually really important for this to work, because like obviously you have to start thinking about, okay, if I'm going to write a proxy that proxies traffic to AWS API Gateway, it's like a double proxy. It's really weird. I need to make sure that when you send the request to the proxy, like the whole thing doesn't block, right? Because while it's setting up API gateway endpoints in the cloud, quote unquote, you actually want it to process other requests as you send them into the proxy, right? So like synchronization, in this case, async IO, it uses async IO on the back end. So in this case, it's async IO tasks, but you can think of them as like threads or background threads. So the synchronization between the threads and the actual way the proxying happens and redirection happens has to be built in a way where the whole thing just doesn't block the fuck up every time you send a request. So that's what I wrote. So, but what DoubleTap is essentially a local proxy that you spin up, right? But it then takes your traffic, HTTP traffic, and then seamlessly proxies it through AWS API gateway. And the end result of this is that like the end service you're trying to access sees a new IP address every single time. Okay, which is, you can start thinking of like all the possibilities that offers, right? And on top of that, someone, I'm gonna put I'm still working on the documentation, but I'm gonna put his name in here once I go back and find the tweet where Mike tweeted it out. So basically, Mike, the guy that wrote Fireproxy, tweeted out, "Hey, do you know if there's a way of rewriting the X forwarded 4 header in API gateway?" And it turns out, yes, there is. And someone tweeted back to him saying, "Hey, you just have to do this," and he actually submitted a pull request to the Fireprox project. So I re-implemented that as well. So on top of getting a new IP address, a new IP address every single time, you can also fake the IP address in the X forwarded 4 header. Okay, so what the end service sees is a new IP address on every connection and a fake IP address in the X forwarded 4 header. So this way, like you're basically hiding your IP address no matter what, which is fantastic. And this has got a whole bunch of pros to it. I'm just gonna turn down the music here because it's actually blasting in my ear. Make it stop. Hold on one second. Oh, no, that just muted it. Okay, that's better. So it's got a whole lot of pros to this. It's much easier to set up and use because like traditional approaches, I mean, at least stuff that I'm familiar with, right? Like from that people have done, like spun up like a bunch of EC2 or DigitalOcean droplets and installed OpenVPN on it and did all this, a lot of other shit that just, just to proxy your freaking traffic through those nodes, which, works, but it's, there's a lot more overhead than this. And what's amazing about this is pretty much free, which is amazing, because the AWS API gateway, they start charging you if you go above 1 million requests, which is, the odds of you going above 1 million requests are very low. Even if you do, it's something ridiculously cheap. I forget, it's like 1 cent per request after 1 million. It's just ridiculously cheap. And also you have a much greater pool of IPs, right? Because if you did do this the traditional way, you'd have only a specific set of IPs. So it would be limited to how many EC2 nodes or DigitalOcean droplets you spin up, obviously, right? Also, you're trusting you're proxying your traffic through AWS instead of some random person's proxy server on the internet, which has pretty major advantages. So you don't have to worry about, especially if you're testing clients and stuff, you don't have to worry about, those people intercepting your traffic. And, trust is relative. It's subjective, obviously, but, I much rather prefer my traffic going through AWS than, some random dude's proxy server, right? And also the IP addresses that the end service sees, so that the end service that you're hitting sees is an AWS IP, okay? Not accounting for the X forwarded 4 header. I've also encountered some weird shit regarding while testing this, regarding how certain services process see what IP address you're coming from, because some services actually look at the X forwarded 4 header if it's present, as opposed to the actual remote IP address, if that makes sense. So, like, in some of the examples I'm going to show you in a second, like the ifconfig.me service takes the X forwarded 4 header, and when I proxy my traffic through DoubleTap and hit ifconfig.me, for in the remote address field, it actually says unknown or unavailable, which is super weird. So it's actually just like trusting my X forwarded 4 header as opposed to actually looking at the IP address, which is freaking weird. So yeah, it's got a lot of pros. So there are some cons to this as well. So one of the major cons is that you have to wait 30 seconds to receive back a response when you try to proxy to a domain for the first time. And this is because you have to wait until the AWS API endpoint stages, which can take up to 30 seconds. Okay, so the way this works is that whenever you proxy your HTTP traffic, the DoubleTap takes the URL you're trying to reach, right? Sends that to AWS API gateway, creates the API gateway endpoints, right? And then stages the API, okay? And that API staging process can take up to around, at least in my testing, around 30 seconds-ish, okay? But subsequent requests to that same domain, once that endpoint is created, you don't have to worry about that. Like that, you get right back the response with normal response times. So that's the main. So that is by far like the major limitation to this technique. But considering all the pros, I think this is not that bad. What's even better about this is that DoubleTap actually sets up those AWS API gateway endpoints. I keep saying that, but there's no way of avoiding that, on multiple regions at the same time. So your IP pool, quote unquote, is even greater than if you were to do it on one region, okay? And it does this asynchronously. So like when you send, and I'll show you in a second, but when you send the request for the first time, you'll see like the output saying, hey, I'm setting it up on like 10 regions by default and all that jazz. So yeah, so that's great. In terms of defense, which is also outlined in the documentation here, in terms of, where is it? There it is. So in terms of defense, it's actually pretty simple. So there is a Amazon API Gateway ID header sent every time a request is sent through API Gateway. And there is no way of overriding this. So as opposed to like the X forwarded 4 header where you can override it, you can't overwrite this header. And this header contains the API Gateway ID, which from what I understand, I'm not exactly sure about this, but from what I understand, it's a base 64 encoded value. The value, once you decode it, is just gibberish. It's like just hex. So I'm not exactly sure if it actually identifies your API gateway, but I mean, I'm assuming it does. And I'm assuming if you gave that to AWS, they can tie that back to an account, which you can then use to file an abuse complaint if you really had to. But the reality is, though, nobody is looking for this header. And also it might break a lot of other things. I'm not sure, to be honest. And what's also very interesting is that this approach doesn't work. Like you won't be able to proxy to another service hosted on AWS API Gateway, which is weird. It's sort of like I started calling it cloud. It's a cloud judo move where you're using AWS API against itself, which is weird. Is there any rate limiting per minute hour by AWS? No, there is not. There is absolutely no rate limiting. API Gateway is designed to have a fuck ton of traffic going to it. So there is absolutely no rate limiting. I've been using this a lot for OSINT scraping, as you might imagine. One of the gazillion applications for something like this. I've been writing a tool called Entropic Foresight, which is basically like an OSINT Python library. I haven't released it yet. I haven't released this either. This is, I mean, unless you're sponsoring me on GitHub, but yeah, so that's in the works as well. There is no rate limiting, And I'll show you some practical examples in like once we get into the demo. But like you can scrape Google, Bing, like all of the things all day with this, and it just works. And he plans on adding Cloudflare workers as a gateway. I found workers a fantastic way to bypass servers only want less than Cloudflare. I actually haven't looked into Cloudflare workers. I'm gonna take a look. Oh wait, that's Cloud, not CloudFront, Cloudflare. Okay, Cloudflare workers. I have not looked into that. I will take a look at that. I've been actually trying to find other ways of doing the same thing with other services. Like I looked into Alibaba. Alibaba is the only other service that sort of has the equivalent of API gateway, but the problem is it doesn't work with SSL stuff. So like it works like you can proxy traffic to Alibaba's API gateway endpoint, but if the service you're trying to hit as SSL, it won't work for some weird fucking reason. I have no clue why. The another way of doing the same thing is you could technically use lambdas for something like this. However, it would definitely cost a lot more and not be as fast. At least what I think. I would have to test that though. But yeah, no, I'm not actually don't know about the Cloudflare workers, so I'm gonna check that out afterwards. So I'm not sure if I will release this or not. The sponsors, if you're a sponsor me on GitHub, you have access to this. But I'm not sure if I kind of don't want this to go away, to be honest. So while I'm all about like sharing the knowledge, at the same time, I don't want to release it and like they fixing this, if that's even like I'm not sure if that's even fixable, to be honest. But yeah, I'm still deciding on that. All right, so let me zoom in here. So I guess I'm gonna show you a demo of this. Okay, so that might be a little bit too big for my tastes. No, go away. Let's put something on that isn't this. Okay, let's put that. All right, so it's completely Dockerized. So if you download the repo and stuff, right now, if again, like to people who are sponsoring me, I don't have a good way of giving you access to the image, because the only way I can do that is through Docker Hub, and Docker Hub actually charges a fuck ton of money for multiple users if you're an organization. It's like $300 a year to start out with, and plus $5 or $7 per user. So I have to come up with some kind of way of providing you Docker images. I kind of want to stick with Docker Hub, but I think I don't know. I'll figure it out. But the way you can build the image, because you have access to the repo, so you can just build it and pull down the image. I already did that. Whoa, what the hell? Okay, 1 second. That went crazy. So you can build the image. Once you have the image built, you can then just run it. So what I'm going to do here is, I already have this set up just because, demo gods. Have you tried using a PC instead? You have no idea, man. Yeah, I have. Yeah. Macs are great and all, but sometimes they drive me absolutely fucking insane. Thought of using GitLab for the Docker repo. Yeah, I have, but the problem is I'm sort of tied to GitHub now because of the sponsors thing. I'm not exactly sure, because it would be a pain in the goddamn ass if I told everyone, hey, sponsor me on GitHub, but then like you have to go to this self-hosted GitLab server. Yeah, that would be a pain in the ass. So I'm still figuring out the infrastructure. This is, and incredibly enough, like a use case like this is actually somewhat difficult to get. Like, it's a weird use case that not a lot of services are meant to work with. So yeah, but I'm gonna have to think a lot about the infrastructure and stuff and get that set up. But yeah, once you build the image, you can run it like this. So in this M file are my AWS credentials. obviously, like, the thing needs AWS credentials in order to work, right? Because it's hitting up the AWS API gateway. In terms of, if you want to know like how it's built, the libraries it uses. Get rid of this thing. So it's pretty, in terms of dependencies, it's not that bad. So MITM proxy is by far like the biggest dependency hog, quote unquote, because it has a fuck ton of dependencies. For actually communicating with AWS, Bodo, the official Bodo library, does not have async APIs yet. So thankfully, there's AIO Bodo Core, which is amazing, and it has async APIs, so you can use async IO with it, which is fantastic. And that's what I'm using to actually communicate with the Amazon API. In terms of code, it's not that bad, although they recently changed the API to the library, AI Bodo Core that is, and they have this like context manager shit, which I had this wrapped up in a class, and they changed the API, and now I had to like read, like, look at this, like, what the fuck is this AI exit shit? It just bothers the fuck out of me that they changed it that way, but it's not that bad. Like, I had to just like add a little context manager here at the beginning, and everything sort of worked, so it's not that bad. But in terms of like for the code that actually interacts with AWS, it's like 500 lines, and you guys are not actually seeing the entirety of that screen, so I'm gonna move that over here. Perfect. It's like 500 lines of code with various classes. The class that wraps up everything and like concurrently spins up shit across multiple regions is like 40 lines. Counting for all the async IO gather calls and that kind of shit. The biggest issue to solve was the synchronization, which isn't exactly the approach that I went with isn't probably the best, but it works. So screw it. So it's basically just like creating a async IO event for each URL, and once the like proxy endpoints are created, it just sets the event, and all the other tasks. All the other tasks just go and do their thing. And the actual add-on itself, like the MITM proxy add-on itself, is like, 100 lines of code? So it's not that bad. And it gets pretty easy to work with. So this is like where really the magic happens here. So like this request hook, this request function gets the request, it gets sent like the request of the proxy. And then you call flow.intercept to tell MITM proxy to hold that request until you call flow.resume, which gets called up in the redirect coroutine. The async IO create task function is what actually calls the proxy request coroutine, which is up here. This is a weird world to work in just because of MITM proxy being asynchronous, but the actual events are not. So like the request event, like all of the events that are available in the add-on system are not asynchronous. So it's a weird world to work in where you have to like mix sync and async shit together. Thankfully, there's this handy dandy sync async library, which takes a lot of that pain away, especially like here, because you'd have to pull some weird ass shit to actually get a coroutine to run in a synchronous function. Thankfully, that library takes care of everything, and oh my god, if you take a look at that code, it's just what the fuck is going on. But it's fine, it works, and it waits for the coroutine to finish. So that's the point. And this is where the magic actually happens. Like it chooses one of the proxy URLs at random. I am going to be implementing like some tweaks that you can do to it. So like it uses like a round robin approach as opposed to completely at random, right? So because it would be good to cycle through each proxy URL instead of choosing one at random, in case that might help with like getting more unique IP addresses. I don't know, but it'd be a cool feature to add. And this is where like we replace the forwarded for header, right? So the way it works is that whenever the API endpoint is created in such a way where when it receives this my X forwarded for header, it'll overwrite the X forwarded for header, which will be seen by the actual end service with a random IP address, which gets created using the Faker library at the moment because it's just the easiest way of doing it. I tried other ways of doing it, like creating a random IP address, and if I found that, so initially I was creating a random IP address just completely at random, not even validating if it was okay or like if it was valid or not. And wouldn't you know that some services actually do check if the IP is valid in the forwarded for header. So I was getting banned by, I think it was VirusTotal. If I remember, I was trying to scrape VirusTotal with this. I forgot what service it was specifically. But yeah, so you actually have to have a valid IP address in there because otherwise I found that some services will just reject the connection. And it also randomly replaces your user agent, which is handy, especially like if you're trying to proxy like Python scripts. So you don't have like a request user agent or like an HTTPX or AIO HTTP user agent. Are you using Yes, I am using the UHK mouse keys. Yep. That's exactly right. The fact that you can even, like, that just by hearing it is crazy. For those of you wondering, I have a UHK keyboard, which you have no idea how long it took me to get used to this thing. But basically, you never have to use a mouse again after spending probably like 3-4 months to get used to how it works. But yeah, it's worth it. It's worth it once once you get used to it. So that's basically how it works. I mean, it's actually code-wise, it's not that big of a deal. I was surprised to actually see how easy it was to work with API Gateway as a service and stuff. All right, so I'm going to spin this thing up. Let me move this out of the way. All right, I'm going to spin this thing up. So yeah, Docker run. Good to go. And it should work. It's thinking about it. Okay. So the first thing it does is it checks for AWS credentials and in the environment variables, which I'm passing through to Docker. But it also checks for them in your .aws credentials file if you're running it locally. And you can run it locally. Like if you install it from source, you can just run it with the mitm dump command, which comes with the mitm proxy installation. So you can run it locally there. So once you got this set up, that's all you really need to do. And it starts listening on all interfaces on port 8080. And actually, this is not going to work because Mac and Docker. So let me redo this. So I actually have to forward the port in Mac because of how Docker works on Mac. Ports are not available. What? Okay. Interesting. I'm not sure what that's all about. 8081? That seemed to work. Okay. Perfect. That seems to work. So now I should have the proxy on port 8081. So that's fine. Internally, though, the proxy is listening on port 8080. So that's all good there. So now to actually proxy... Yeah, correct. You have to port forward twice because of Mac. So from my understanding, I'm not exactly a Docker expert. So the way Mac in NAT mode works on Mac is that you can't actually hit the NAT IP address. So you have to port forward the port locally and just use your local host to actually access a service in a container, which sucks balls. But yeah, that's just how it works. It's complicated. Mac just works. TM. So just to give you an idea of how this works, what I'm going to do here is I am going to use HTTP Py, which is essentially just like a Python version of curl. and I am going to proxy a call to I'm going to try to hit ifconfig.me, which will give me back the IP address of my IP address. So hopefully I'll see a different IP each time I do this request. So there you go. So now it's doing its thing, right? So it's setting up the API. It's concurrently creating the API gateway endpoints on 10 regions at the same time. And then once it finishes doing that, it lets the request through and seamlessly redirects the requests that you're making to the AWS API gateway endpoint. Okay, and you can see that my IP address is obviously not my IP address. And this is what I was talking about, right? Remote host unavailable for some weird reason. I'm not exactly sure why. The service takes into consideration the forwarded header, which is down here, but it, for some reason, like when it sees the forwarded header, it doesn't actually show you your IP address, which I have no clue why the fuck that is, but that's just how it works. So if I do it again though, like before we had to wait like around 5-10 seconds ish for the request to go through, right? But now it's instantaneous because once it sets up that endpoint, you don't have to do it again, and it just lets the request through and proxies it through. It keeps an internal dictionary of like all of the proxy URLs that it's set up, so you don't have to keep doing that again. The question starts becoming like, what happens when you're doing this at the same time, right? And that's a really good question. So what I'm going to do is I'm going to Control C this. I'm going to give it a argument equals true. So this is the set, the -- set is just a MITM proxyism in order to pass arguments to the proxy add-on. So I'm giving it the cleanup true argument, which basically tells it to, before it actually starts everything, starts accepting requests, go out and just destroy all of the proxies you've previously created to start fresh, which is handy. So that's what it's going to do now. So it's going to unstage and destroy the proxies. This takes a little bit, but it's doing it at the same time. So it's not going to take that long, right? So the question starts becoming, okay, like, that's great, Marcello, like, you know, handling one request, bravo, right? But, okay, so this is where things get interesting, right? Because of the way the async IO tasks work, right? It can handle multiple concurrent requests. So what that means is, like, say you have something like this, and so this is what this is going to do, is it's going to spin up 10 concurrent async IO background threads, right? So, and it's going to request the ifconfig.me service, right? So we're going to be basically 10 concurrent HTTP requests to that service, right? And we'll see how the proxy handles that. And you'll see that I'm jinxing it now, but it should work, especially since I just tried this before the demo. Okay, so in order for this to work, so in order to tell HTTPX, the library that I'm using to actually do the async HTTP requests, I need to give it the HTTPS proxy environment variable, and I'm going to change this to 1. So what this is going to do is the underlying HTTP library is going to pick that environment variable up, and it's going to know where to proxy its requests at, right? So we're now going to run 10 concurrent requests at the same time through the proxy and see how it does. So there you go. So you got all the connections happening at the same time, and hopefully it works. Nope, this is not working. Fantastic. Yay. Demo fail. What happened? Let's try this one more time. Actually, you know what? Oh, do you know why? Because, yeah, cleanup. Okay, so I think there's a bug in the way the proxy like cleans itself up afterwards. So what I'm going to do is I'm just going to switch this to I'm going to switch this URL in the script to google.com, which doesn't actually, which why not? Let's see if that works. Because otherwise I'd have to go in and manually delete the demo, manually delete the proxy on every region until I fix this bug. I just discovered this before streaming, by the way, this bug. Like, so it's just absolutely, it's demo gods. Yeah, so like if I fire this up again, you're gonna see that it's gonna start retrieving, hopefully. All right, it's gonna retrieve the stage proxies. Oh, so it's not retrieving the stage proxies. Interesting. All right, hold on, let me try this again. Hold on, now I'm curious. Let's go back to here, change this to ifconfig.me again. You know, you'd think, like, right before streaming, you discover bugs. It's the best thing in the world. Alright, I changed it to ifconfig.me again. Because, okay, so just to give you some background, like, if you already staged proxies beforehand with this tool, it'll pull those down and add them to the internal dictionary so you don't have to stage them again, right? Because it would be sort of stupid if you had to do that again. So the fact that it didn't retrieve the stage proxies indicate that maybe the cleanup just happened. So let's try this one more time. It might be, and this is something that I still have to work out, it might be because, like, the cleanup, like when you call the API, the AWS APIs to actually destroy the proxies, it takes a while for those to actually get destroyed. I'm not exactly sure. I have to experiment with that. Let's try this one more time. Hey, now it works. Okay, so that's probably it then. Okay, so this is 10 concurrent requests. Perfect. Okay, so now it worked. Okay, so this is 10 concurrent requests at the same time. And you see that, like, it stages everything and only allows the concurrent requests through when everything is staged, then seamlessly redirects your HTTP requests to the AWS API endpoint, which in our case are these. And you could actually hit those URLs now because they're completely unauthed, which is, you know, it's sort of a thing. Quite frankly, like, it's a decent random URL, so you could add authentication, but it's not, I think this is fine as it is. If you actually hit these URLs in your browser though, you would actually be, you'd actually see the ifconfig.me service. So like you can actually access these. But in the response here, you see that every single request gave back a different IP address. So this is one IP address, this is another IP address, this is another IP address, another IP address, and so on and so forth. So every single one of these IP addresses are different, and they're unique, which is fantastic. And the setup process is much easier than freaking spinning up like 20 EC2 instances, 20 DigitalOcean instances, on top of being incredibly cheaper, and the network overhead is much less too. So like you can actually get decent speeds with this, as opposed to like using a VPN connection into all of your proxy hosts, and it avoids using a random service on the internet. Okay. But the real power comes into play here, like when you're password spraying, right? You can start thinking about the opportunities that this gives you. I have done this. I have password sprayed the MSOL Azure API endpoint through this before, and I forget what the client had. They had some sort, I think it might have been ATP, Defender ATP hooked up, or some Azure service that notifies you if password spraying attempts happen. And the report just contained, I think it was like 300 different IP addresses trying to spray. So like you can and obviously it was an external, so I wasn't worried about stealth, but you can get really fancy with this and like customize the jitter between sprays and stuff, which you will be able to once I drop the new spraying toolkit update. That's almost done as well. And you start seeing a theme with all of my tools that they're going to have like Like they're going to be built around proxy support because all of the shit that I'm doing now can technically be used through this and with amazing consequences, right? Witness Me can also be used through this. As it stands now, it's a little bit finicky because of the 30-second delay, because obviously if you're actually loading JavaScript on a web page, right, it's going to request like a gazillion different domains and URLs because of all the cancerous tracking and stuff that it's at, that every page is loading, right? So that's why I'm going to be implementing allow deny lists into this tool so that you can allow specific domains and URLs to get proxied and others not to. So that will speed up that whole process as well. And also I'll also be adding the domain preloading feature, which is basically you can just give it like a list of domains and it'll load those up in AWS API Gateway before sending requests through it. So that works as well. But like you can think of like all the scraping opportunities for this too. Like you can scrape Google all day with this, no issues whatsoever. And this is exactly what I do with my OSINT tool, which I still have to get working. I rewrote that thing like 2 freaking times already, and I'm still not happy with it. But it'll get there one day. But yeah, if you just change that to Google, like no problem whatsoever. So if we just get that out of the way, right? Proxy's still running, so we just run that same script again. And the output isn't scrolling. There you go. There you go. So it's setting up all of the API endpoints, and you can see from the logging, right? These are all different regions. So it's doing it at the same time, which is fantastic. And now we're just waiting for the APIs to stage. So another interesting thing about this technique is that, okay, what's that all about? Oh, yes, fun. So what's going on here is that google.com redirects to www.google.com. So what it's doing is it's staging it twice now. It's staging google.com and www.google.com because it got redirected. Fantastic. There you go. So there's 50. So now it decided to give you the response. So there you go. Yeah, google.com redirects to www.google.com. And it automatically takes care of that for you. So if there is a redirection, like it'll stage a proxy AWS endpoint to that domain that you got redirected to. And it worked. Fantastic. That's actually the first time I've tried that. So I know it works now. Yay. So this is google.com. This is all like googles.com web pages. But yeah, you can totally scrape Google all day, no problem. Another interesting fact about this though is that it's like when you take a look at this output here, API seems to have staged. So the AWS API, like the Boto library, doesn't provide a way, or AWS doesn't provide a way of actually determining if a API, when, or at least giving you a way of finding out when an API has actually staged, right? So there isn't a way of like getting a callback, or there is like no API endpoint to know for sure when an API endpoint has staged, if that makes sense. So in order to detect when like the actual gateway API has staged, I need to do basically a signature check. And the code for that is here. And it's like the stupidest thing. And I don't think there is a way of knowing, like, I don't think there is a way of actually confirming officially if a API gateway has staged or not. So this is the function that actually like checks if it's staged. And it's just a signature check. So and this is just shit that I found during testing, like ways of knowing if the API is staged or not. So it's checking if it's not a 403, if the response status code is in a 403, and there's no X Amazon error type header in the response. That's one way of knowing if the API is successfully staged. You also get a JSON response with a missing authentication token if an API gateway has not staged yet. Yeah, And those are pretty much the only ways. So the way this works is that when it actually creates the API gateway stages and deploys the APIs, it'll spin up other background tasks which poll each proxy URL until they're staged. And then after that, after those background tasks finish, that's how DoubleTap knows that it like the staging process is finished and it can allow those requests through. Okay. It's a really roundabout way of doing things. There isn't a way of actually doing this officially from what I understand. So this is the best that I can come up with. It's sometimes a little finicky because it's like the responses, because it's all load balanced. So sometimes what happens is that these threads actually get a valid response back, but then a subsequent request to that same proxy URL actually returns a bad response. So like one of these responses, if that makes sense. So like, because it's all load balanced, it's not very predictable, but it works most of the time. That's the important thing. It works like 99% of the time it works. And the fact that it just worked with a redirection is amazing. So I'm happy about that. That's fantastic. Yeah, it takes care of redirections for you. So if you are like me and I'm a dum-dum and I forget the fact that Google.com actually redirects to www.google.com, then yeah, it takes care of that for you. So no problems. And you'll never get banned. Like there is not a single service that I've encountered so far that actually bans this or detects this in any way. Like the only caveat to that is obviously that if the end service you're trying to access is using API gateway, the proxying won't work because you can't actually proxy to another service using AWS API gateway, which is super weird. But thankfully, not a lot of things are using API gateway, with the exception of, and this is the only service that I found so far that actually uses it, is, what is that? Oh my God, I'm blanking right now. It's the browser fingerprinting thing. Oh, for fuck's sake. Browser finger. If I just Google this, it's going to come up immediately. It's like the most famous browser fingerprinter thing. Browser fingerprinter. I'm blanking so hard right now. No. Web something? Oh, there's like an extension for it. Oh, whatever. Okay. But like there's an extension for it and everything. Nah, it's not POF. It's an extension. Like you can do it on your you can just put it in your browser. What is it? Yeah, Wappalizer. Thank you. Yeah, Wappalizer. Yeah. So Wappalizer is the only freaking service that I've found so far that actually uses API gateway, because I was obviously trying to script up for the OSINT tool. I was trying to make this not fingerprint browsers, sorry, fingerprint websites, my bad. I was actually trying to automate like making Wappalizer fingerprint websites for me, so I can get like cool data and stuff. And they actually use API gateway, and it was returning all this weird shit, and it wasn't working. And I was wondering what the hell's going on. It turns out this uses API gateway, and the way I found that out is because when you actually query their API, which is here. When you actually query their API, it returns the same Amazon Gateway API ID header. So that's you can fingerprint services pretty easily that run API Gateway. This is the only service so far that I found that actually doesn't work just because it's actually hosted on API Gateway. So kudos to Wappalizer. They've pulled a Cloud Judo move there, and they've used API Gateway against me, which is crazy. But yeah, this is the only service that I found so far that uses API Gateway. I've tried VirusTotal. VirusTotal works. I've tried basically everything at this point. I'm trying to think if there's something that caused issues with it. I think VirusTotal actually caused a bit of issues, but that was actually before I added the multiple regions update. So I'm assuming what was going on is sometimes the IP address was repeating. I'm assuming that's what it was, but I'll find out for sure, I guess. But yeah, now that it actually spans across multiple AWS regions, and now that it actually spans across multiple AWS regions, it shouldn't have that issue. So you won't actually see any repeating IP addresses almost at all, which is fantastic. So yeah, that's basically the gist of DoubleTap. In terms of releasing this, I don't think I will, at least for the near future. Like maybe if I feel like it, like I'll set a specific like sponsor goal on GitHub, and if I reach it, I might. But to be honest, I'm not sure if I will. But yeah, in terms of like, but you have access. Like if you're sponsoring me now, you have access to it, and the documentation at this point is extremely thorough. It has basically, I think, everything you'd ever want. I can definitely expand a lot of the usage section, but it has a decent amount to get started with. So you should be good to go there. There's also detections and OPSEC considerations if you're using this on red teams, which is helpful. But yeah, so you'll start seeing a bunch of themes, like a theme in the tool, in some of the tools that I start releasing from now on, which will be like based around like having pretty robust proxy support, because all of this shit is going to be designed to actually go through this. So it's like a toolkit that I'm building up at this point, which is cool. So yeah, I really want to get Witness Me to work through this, because at that point you can actually like do headless browser scraping and or just like screenshotting, which is awesome. Why does API Gateway not have waiters? Yeah, that's a good question. That is a really good question. I've been like, to be honest, I'm gonna double check that, because I didn't know there was an actual term called waiters. However, I'm pretty sure there wasn't. I'm pretty sure there isn't, just because I have poured through that fucking documentation, and if there was something called waiters, I would have noticed that, I think, because that's exactly what I want to do. So, oh, it's not there. Perfect. Okay, I'm glad. Whew. I'm glad, because you have no idea how long it took me to actually get this to a point where like this signature check was reliable. So good. I'm sort of glad it's not there, but yeah, that's fucked up. They should totally fucking fix that shit and get some waiters in there. So yeah. So that's that. It currently uses 10 AWS regions. If you wanted to add like the Asia regions, you can do that as well. The latency and the requests might suck a bit, but you know, you can totally do that. But I want to flush out. I want to add those allow deny lists and the domain preloading, which should help, especially if you're trying to pipe headless browsers to it. And then once I got that set up, you can start scraping LinkedIn all day, which is exactly what I'd like to do. That'd be cool. Cool project to do, scraping LinkedIn through this, and stuff like that, because why not? Yeah, so that's DoubleTap.
They talk a lot, but can they hack it? Sending it for 6 off the planet.